Hello, hello. Welcome to another session on Blazor. I think most people, let's turn on Focus Assist here. Okay. So I think everybody missed my first broadcast. I had 0 viewers. And I didn't have my live broadcast set up properly to save it. So it's not available on Twitch. It's not available on Mixer or on YouTube or anywhere. But you know, you live, you learn, you hopefully get better as you do it more. This is live coding number 2, live stream number 2. So to recap what I'm doing here, what I'm starting with is I am learning Blazor. I'm going to be going over all of the tutorials, the documentation that they provide, and then I hope to start going over people's blog posts and implement some stuff there. Hopefully learn a bunch about Blazor. Hopefully teach a bunch about Blazor. I do think it is going to be pretty key going forward. I think it is going to be, you know, part of the future of ASP.NET Core. For any of us C# developers, .NET developers, web developers, I think this is going to be the future, but time will tell. We shall see. In either case, we're learning some new things, and we're gonna get going. In fact, I'm close out of some of this here. I'm going to start with something that I went over last time. New practice. Well, everything's basically new. But as we were going, I had some questions, some things I wanted to have answered. Questions I wanted answers to, some follow-ups to do. I found a bug that I wanted to report to the GitHub repository. So let's start there, and then as we go, we'll probably come across more questions, and we'll ask and answer those next time. But quickly, I have not reported the bug yet to Microsoft. I've been pretty busy, but we'll get it over to them. But let's go to the questions. So what was the first publicly available build of Blazor? So I feel like the first time I had seen it mentioned, it was already up to 0.3.0. For those who don't know, it is very experimental at the moment. You can see there the flag, experimental, in the upper right corner there, documentation. It is work in progress and a beta, but it was available at 0.1.0, so I just hadn't seen anybody talking about it in the people I follow, in the places I follow. Okay, so number 2, are F# and VB.NET supported? So neither of them are directly supported. It is C# currently only. However, I did see just through a quick search, an F# library helper, it seemed like, or a helper for Blazor, allowing you to do, I didn't look into it too much, but looked like you could basically do Blazor with F#. Maybe somebody can, if somebody looks into that, they can update us at that time. At our tag helpers supported. You know, when I first looked this up, came across the this Blazor issue 310, which basically said no, they're not. That components are supposed to be, you know, better than tag helpers as far as Blazor is concerned. But as I've been following the GitHub issues for Blazor, I've seen people talking about tag helpers, so now I'm a little confused. So let's start our stream notes for today, and let's ask this again. Are tag helpers supported? Because, you know, I'm not sure again. Looking at this GitHub issue, it would say no, but again, looking at more issues or what people are currently talking about, I would say yes. Who knows? So, hot reload. So, hot reload is still in the works according to you know, these issues in this pull request. Now, what does work? It was working for me. It works under IIS Express. Is I can make changes to the code, and I don't have to recompile. I just have to refresh my browser, and it automatically loads up the new code. So that's pretty close. That's pretty good. But it doesn't do it. There isn't something that on save of a file, you know, causes the browser to automatically refresh and reload. Some of this stuff was saying that .NET Watch is one way that allows us to do it, but it is essentially still in the works, not quite ready. As far as can you swap out dependency injection containers? I didn't see any specific documentation saying whether or not you could. I know that you can for ASP.NET Core, and Blazor is based upon ASP.NET Core, so I've got a feeling the answer is yes, but we basically would have to follow the instructions on the ASP.NET Core documentation site for how to swap out the DI container, and then see if it works. So that's something we'll try. Okay, so let's close that down, put that away. Now, last time we went through the getting started, which basically just create the project from the template, the base Blazor template. Went through the build your first app steps, and yeah, build your first app. Let's see. Trying to remember. It's only been 2 days, and I feel like I've forgotten. Yeah, so all we did, we made it through those first two. So I'm going to move on. So as I said, this is going to be a multi-part series. Plan on initially going through their documentation, and then, you know, finding blog posts from people, community stuff, all of that, trying to add to our knowledge of how Blazor works, how to use it, all of that good stuff. So moving on to the introduction. I'm not sure there's much here for us, but what we went over last time and we're going over right now is that Blazor uses the Razor HTML markup with C#, and it runs that in the browser via WebAssembly. So you get full, I believe full .NET standard support via Mono, compiled to WebAssembly in the browser. That means that it's all running, well, I say all running client side, but really you get to have your option of how much you want or what you want running client side and what you want server side and communicating to client side. But so you can have a thick client, a fat client, where they download the entire application and it all just runs locally, and all in the browser. So why I talk about why you should, what exactly it's doing. So the Razor files are compiled into assemblies. The assemblies in runtime are downloaded, and it uses JavaScript to start the runtime and load the assemblies. Blazor components. So this is where we start getting into the how it works, not how it works, how you put together everything. So every page in Blazor is considered a component, and each component is a class. So whether it's a full page with a URL that can be routed to, that is a component. That component would then be made up of smaller components, be it things like sidebars or menus or buttons or anything, any sort of specific content, and so on and so forth. So components can be nested. They're created with Razor. They can also be created with .cs files. They can be shared from libraries and unit tested without requiring a DOM. That's nice. So currently supports different layouts, routing, and dependency injection. Code sharing. So as I said, this is .NET Standard compliant. So any library that is Net Standard 2.0 or higher is going to work. Well, I say work. It's going to be acceptable and loaded. But as it says here, if you're trying to do something like access the file system, well, that's not really something the browser does for you. You're going to get your platform not supported exception. But other things it can do, other .NET Standard libraries are going to come in just fine. Let's stop here. I'm going to make sure that I've got everything working. Doesn't look like I've got anybody watching specifically, so I don't know that I have any chat coming in, but I'll make sure. Let's check some of these. No, I think we're okay there. So hopefully we'll get some people watching at some point, and we'll make sure chat actually works. Okay, so moving on, JavaScript interop. So JavaScript libraries can also work with WebAssembly. There is a section here, JavaScript interop, that we'll be getting to. But because this C# is running on the client where JavaScript would be running as well, the two libraries, or whatever libraries you're using, can call each other via the JavaScript interop. Optimization, deployment. Okay, so here's where yeah, .NET runtime and assemblies are cached, responses are compressed, net assemblies are removed. So I don't know how many of you are familiar with Xamarin. Xamarin has a process, their linker process, which strips out code while compiling. It strips out the code paths that aren't used, that aren't accessed. If you've got a library with 50 classes and only 2 of those classes are actually used, the rest of them are removed when the app gets compiled down. I would guess that this works the same way. Deployment. So as I said, it can be a standalone client-side app, a thick client that comes down. The file can be hosted anywhere anywhere you can host a file on the internet. Azure Storage, Azure App Service, GitHub Pages, as it says here, IIS has static file server, Node.js services, servers, any of those. It can also be deployed as a, as it says here, full stack core app, meaning that there is a server side component to it as well as a client side component to it. Okay, so moving on to component classes. Apps are written using components. Each page, let's open up my Solution Explorer here. Each of these pages is its own component, which we could see here. So in our first our getting started, so counter is just part of the template. Going back over this, we've got our header, we've got our page, I don't know what that's called, but it denotes that this is a page and can be routed to. Here is the URL, or the portion of the URL, the path for routing. Current count, we're displaying a field here from the page, variable, current count. And we've got a button with an on click that calls this method increment count. Right? So when you click the button, this variable changes, and automatically this changes. We don't have to do anything else to update this this paragraph, other than this, increment the current count. So as I said, this is a page and can be used as a page, or can be routed to directly. If we take that off, it's still a component, it still works just fine, but you just can't route to it anymore. But, however, it is also a component. So here's our index, our root page, and we can embed that existing, and let's go ahead and do this. You can embed that component into another page. Excuse me. Okay, here it is loading up. like I've got a viewer. Let's see. If they see some chat, if we've got that set up, maybe they'll message me, and we can make sure we're all set up and configured properly. So the counter. Here's our index. Here we can see the counter page, as I said, page counter. Works like that, counts 1 by default. However, on the home page, we put it in, and we gave it an increment amount of 10, and look, there it is. And as I said, there's nothing we have to do to tell this to update. It automatically does it for us. It's pretty nice there. Oh, we lost our viewer. Oh well. So coming back, components, dynamic rendering logic. If you know C# Razor, then you're gonna know how to do this. It's pretty straightforward. You've got your HTML and then your functions, wrapped in functions, and any variables and any of your the specific code you're going to need there. Using components, headers and component, we just went over this. Component parameters. So components can have parameters like we saw here, increment amount equals 10, parameter increment amount becomes available. Child content. So components can set the content in another component. The assigning component provides the content between tags and specify the recipient. For example, parent component can provide content that is to be rendered by a child component by placing the content inside the child component tags. Okay, so here we've got render fragment child content at child content here, and here inside the component define the content. Data binding. Binding is done through the bind keyword attribute, which we can see here on our simple to do. So here we've got an input, we've bound it to this value at new to do, and then for the button on click, add to do, we make sure that there's actually text in that field. If there is, we go ahead and add the to do item and we clear that to do. So this does a two-way binding. Since components render themselves after event handler code executes, property updates are usually reflected in the UI immediately. Right, so that's what I was saying. So as soon as this property changes, it is updated in the UI immediately. Now let's see if we can see how that works. Don't. Okay, format strings, date time format values. Pretty straightforward. I don't think we need to. Binding also recognizes component parameters. Following component uses child component binds parent year parameter to the parent, from the parent to the year parameter on the child component. Child component bind year, child component year. Okay, so this is how we can potentially pass down. So we've got the year in a child component, and it gets changed in the parent component. We don't want to have to set it on the child component. We just want to bind it so that as this executes, so the button gets clicked, the year gets changed from 1978 to 1986. This would automatically update to display the new value, parent year, and the child component, because we are binding to the year parameter, we would see it automatically update there. Now let me pause here a moment.
Jackie was going to help me. Did you not leave his backpack?
No, they're in the trunk.
Okay.
Both are backpacks.
Okay, I didn't know, and so I came on in here, and so now they're going to give me a bag.
Yeah, there wasn't any room in either of their cubbies.
I'm going to figure out how to close it up.
Okay.
How to get less stuff in his cubby.
Okay.
All right.
And we're back. Let's see. Okay, so we've talked about that. That is very useful. Event handling. We've got on click, on submit. Any sort of HTML element attribute named on event, on change, let's see, this is event arguments, so we get specific arguments for different types. Capture references across components. Component references provide a way to get a reference to a component instance so that you can issue commands to that instance, such as show or reset. To capture a component, add a ref attribute to the child component, and then define a field with the same name and same type as the child component. So my login dialog, ref login dialog, show. When the component is rendered, the login dialog field is populated with the my login dialog child component. Okay, so this is how we can call to child components by name, essentially. So coming back to our example here. So let's try this one out. Functions. So if we added in a counter, we'll call it counter. How's that for original? if we wanted to be able to reference this specific one, ref equals counter. Now, void change increment. We could set counter dot set parameters. Lifecycle methods. Let's see if we have gotten ahead of ourselves for our parameters. No, I don't think we have, so of course. Parameters dot plenty of gets. How do we set them? Oh, hold on a sec. There we go. So, change the increment from 10 to 5, and we'll do that with a button on click equals change increment. Is that right? To at yep. Okay. And change increment. Okay, so if we refresh our page here, we should see it reload. It's going to start with a increment of 10, change the increment, it's now 5. And there we go. Okay, so pretty simple stuff. Okay, lifecycle methods. On init async on init, execute code after the component has been initialized. On an asynchronous operation. Yep. And on parameter set, called when a component has received parameters from its parent. After render, on after render, called after it finishes rendering. Use this to perform additional initialization steps using rendered content, such as activating third-party JavaScript libraries. Okay, so if you're using something like Bootstrap, and you want to turn on tooltips or something, on after render would be a good time to do that. Or maybe you're using jQuery UI and you want to make a list sortable. Now, on after render would be the time to do that. set parameters. You can override, do stuff before something gets rendered, or before parameters are set. Component disposal with iDisposable. So if you need to implement iDisposable, you can just add the @implements iDisposable and then dispose method. Routing, so you can set up multiple routes via the page directive. You can specify routing parameters. So we could have counter increment. So by default, the counter 1, 2, 3, 4, 5. But using the routing parameter, we could do counter /2. And it should be incrementing by 2. Except that did not work. Let's see. Route parameter, text. Looks like it needs to be lowercase. So let's try that again. Well, that didn't work. Well, let's try and see what we're doing wrong here. By the way, pages in the documentation, it said add pages as text files and name them CSHTML. So text file. Let's try their sample and make sure it works. Okay, Blazor is fantastic. We've got fantastic there. Nice. Blazor is awesome. Okay, well, their sample works. What is the difference other than the fact that we are public here? It can't be. Functions, implements, enhance, layout, specify a layout component, conditional attributes. raw HTML done via the markup string. Templated components. That's going to be important, but why is this not working? Oh, there we go. It is working now. I wonder if it was having trouble routing it because it didn't think it was an integer. I was trying to do it as text, probably, as a string. And by specifying a routing condition, let it know that it needs to be in, or that it can look for it as an integer. Okay, moving on. Template parameters. Templated component defined by specifying one or more component parameters of type render fragment or render fragment T. So let's look at our sample here. Components, table template. So we've got our basic table, right? Table, T head, table header, obviously. T body for each item in items. Use the row template. And for the footer, tr table footer. And here we've got our header is a render fragment. Our footer is a render fragment. Our template is a render fragment of type T item. Items is a read-only list of T item. And the component is called table template, right? And the type parameter, and this is important, is T item. Imagine there can only be one kind of type parameter. Let's see if it's not right there. Let's have it. Can there be more than one at type parameter? Okay, question number 2. So we then get to define it. Table template, table header, and here is the render component for that. Here's the row template, which uses context. There are items, pets, and template context parameters. Okay, so using this, let's come back to our fetch data template file. So this is part of our template where we are getting data from the server. We're grabbing this JSON file with sample data and displaying it up here. And we could utilize a component for this. I mean, obviously the table template we're already doing here. We're only using one, but it's the right thing. Okay, let's see. Type param to specify type parameters. Generic list view component, IAM numeral T. Type parameter can be specified as well. Context. Pet. Razor templates. And this is the last thing here on this page, and we'll finish up for the day. So Razor templates. Render fragments can be defined using Razor template syntax. Razor templates are a way to define a UI snippet and assume the following format. Add tag. So we can define a template in code. And passed as arguments. And then used as used in the HTML. That would allow us to dynamically create these templates in C# in the @functions section, and then just define where they're going to be displayed in the UI and have that automatically come up. I think that's going to be really useful at some point. Second live stream, I feel like we did a little bit better. Actually, I feel like it went a little bit worse today. I was a little more scatterbrained, wasn't as focused here. But I think we got a couple of viewers, which we're doing better off. It's saving, I believe, our broadcast, so people can come look at it later, which is much better off than we were before. But so yeah, thank you for watching. Thank you for joining in. Please hit me up on Twitter, Twitter JSMarcus, or watch me on Twitch, twitch.tv/JeremyMarcus, or you can find me on Mixer, mixer.com/JSMarcus. Yeah, happy coding, and we'll see you later.